In this video, we're going to take a look at the transformations of exponential functions. So let's first write down the rules of transformations. And there's good news. The rules for transformations really stay the same. The function you're looking at is what changes. So like the shape of our graph might change, but the rules of transformation stay the same. So the a value is still that number in the front of our function that's multiplying the function. And when a is positive, it kind of looks like it's regular. It opens up. And if a is negative, it makes our function reflect over the x-axis. Also, the value of a makes your graph change. And so when the absolute value of a is greater than 1, it makes our graph have a vertical stretch by a factor of that value. And when the absolute value of a is between 0 and 1, it makes your graph have a vertical compression. So between 0 and 1 is something like 1/2 is an easy example to think about. Now the h in this case is in our exponent because that's where the grouping symbol is for an exponential function. So when you have a plus h value, it's going to shift your graph to the left. And when you have a minus h value, it's going to shift your graph to the right. Remember, it's kind of opposite of what it looks like. So positive actually goes left, and a negative actually makes it go to the right. And then the k value is something being added or subtracted. Usually it's out back, but it could also be moved to the front if they're really trying to be tricky. But a positive k value makes your graph shift up that many units, and a negative k value makes your graph shift down that many units. All right, so let's just try to pick out the transformations below in this table right here, and then I'll show you how you can also use Desmos to take a look at a few of them. All right, so in number 1, we have f of x equals 2 to the x minus 3 power. Notice they've stated in the directions that the parent function is f of x equals 2 to the x. And so those are the parts that stay the same in each of these problems. What we're looking for is what else is happening. So not worried about the 2, we're not worried about the exponent of x. We're worried about what else is going on. And so in number 1, we see that there's a minus 3 in the exponent. So that is like our h value. And we would just say that that makes our graph shift, since it's minus 3 and h makes our graph shift left or right, we would say that it goes to the right 3, because minus in that grouping symbol does the opposite of what we would normally think it would do. So minus 3 makes it go to the right 3. In number 2, we notice there's a negative in the front. That means the a value is like a negative 1 out front, and so it's making our graph reflect because it's negative. So it reflects over the x-axis. Since the a value is just 1, it does not have a vertical stretch or compression. So it just reflected over the x-axis based off of that a value being negative. And then the 4 that's sitting out back is like our k value, and that makes our graph shift up 4 units. All right, so number 3, I'm going to change that to a positive 3 because I'm noticing it's the same as number 1. So let's take a look. If that was a positive 3, just edit your notes a little bit. Then this would make our graph, notice it's in the grouping symbol again, that makes our graph shift left or right. And since it's a positive 3 now, since we fixed it, it would make our graph shift left 3 units. All right, number 4, we have a 1/2 out front, so that's the value of a. Notice that is between 0 and 1, so we're going to have a vertical compression by a factor of 1/2. All right, and then we also have the plus 5 that's in the exponent. So the plus 5 being in that exponent, it's like our grouping symbol, makes our graph shift left or right. And since it's positive 5, it's going to make the graph shift to the left 5 units. All right, and then number 5, let's see, we have a 5 out front. So our A value is definitely greater than 1. So it's going to have a vertical stretch by a factor of 5. But then we also have -8. So -8 is not in a grouping symbol, so it makes our graph go up or down that amount. And so it's going to shift our graph down 8 units in this case. Okay, so that's it for a few examples of how we can identify the transformations on exponential functions. But let me just show you something that would be really neat if you're working on your homework or a quiz or a test, is let's type in the parent function. So let's just type y equals 2 to the x power, the plain parent function. And then let's type in number 1. Y equals 2, then do the exponent key, but make sure you type it together so it's x minus 3 in parentheses to make sure it treats your function properly. And if you notice, you can easily take a look at the graph and see that from that parent function that was in black to the new function in red, that it did shift right 3, which is what we put for number 1. All right, so let's just change this to look like number 2. So I'm just going to edit a little bit and take out, let's see, I'm just going to take out the exponent having a -3 in it. So just be careful typing all that in. And then you can tell with number 2 that it does look like my graph reflected over the x-axis, because now that red graph is going down. And it also looks like it shifted up 4 units. So it's nice to be able to type that in. So make sure to type your parent function, just the basic one, and then type the one you're thinking about. And it helps you to pick things out. Like if you forget the rules, your graph can show you the rules. So that's it for transformations of exponential functions.